What is up, guys? Gunda Math over here, and today I'm going to be doing some IIT integrals. So I've actually solved these problems before. So in this solve, I'm going to be sharing my I was thinking and how I managed to solve these problems. So sit back and enjoy. So for our first integral, we have the integral from x up the square root of 2 sine x squared minus 1 minus sine 2 x squared minus 1 over 2 sine x squared minus 1 plus sine 2 x squared minus 1. So there's the problems. The first idea I had was we see a sine 2 theta form, so let's expand that as 2 sine theta cosine theta. Doing that in the next line, we get x root 2 sine x squared minus 1 minus 2 sine x squared minus 1 cosine x squared minus 1 over 2 sine x squared minus 1. Similarly, we do it over here, plus 2 sine x squared minus 1 cosine x squared minus 1 as follows. Now we can easily see that a 2 sine x squared minus 1 is factorable. So if we factor it, we get 2 sine squared x minus 1 times 1 minus cosine x squared minus 1. 1 minus cosine x squared minus 1 over, if we do that in the denominator, we get 1 plus cosine x squared minus 1. Now recall, this may look familiar. Recall that tangent of theta over 2 is root 1 minus cosine theta over 1 plus cosine theta. And we have that form, so this is ultimately equal to integral of x tangent of absolute value of x squared minus 1 over 2. Well, let me write this differently. Right? So next, what I saw that there was an x dx term, and we can easily get rid of that by performing a u substitution. X squared minus 1 over 2 is equal to u, as follows. So we have x squared minus 1 over 2 is equal to u. X squared minus 1 is equal to 2u. So we have 2x dx is equal to 2 du. Or in other words, we have x dx is equal to du. So now we conveniently have x dx is equal to du. Therefore, this becomes tangent of absolute value of u du. And then, so this becomes ln u. Then we need to substitute it back. We know the integral of tangent of x is secant squared of x. So this becomes ln of secant, ln of secant of x squared minus 1 over 2 plus c. It becomes ln secant of x plus c, right? Secant of u plus c, our u is x squared minus 1 over 2, so we substitute that in, and that should be our answer. Moving on to problem 2. We have a function f of x is equal to the integral of 5x to the power of 8 plus 7x to the power of 6 over some x squared plus 1 plus 2x to the power of 7 squared dx. And we're given x is greater than or equal to 0. So how can we do this? We're obviously not going to expand the denominator. That'd be too lengthy. And then even if we do expand the denominator, we don't know how to proceed. So we're going to do the common integration technique of actually taking the highest power out of the denominator. So we can take x to the power 7 out, right? Rewrite this as x to the power 7 times x to the power minus 5 plus x to the power minus 7 plus 2. This is, of course, this whole thing squared, so this finally becomes x to the power 14 times x to the power minus 5 plus x to the power minus 7 plus 2 squared, right? So we've represented the denominator like this, so we'll bring the x to the power 14 into a numerator to make our integral 5x to the power minus 6 plus 7x to the power minus 8 over x to the power minus 5 plus x to the power minus 7 plus 2 squared. Now, bingo, we can immediately see that the differentiation of the denominator is in some form of the numerator. Namely, if we let x to the power minus 5 plus x to the power minus 7 plus 2 equal u, we have minus 5x to the power minus 6 minus 7x to the power minus 8 dx is equal to du. Or in other words, we have 5x to the power minus 6 plus 7x to the power minus 8 dx is equal to minus du. So how can we simplify this now? This becomes minus integral du over u squared, I believe, right? So if we, let me just move that up for you. So if we have this becomes minus u to the power minus 1 over minus 1. This is equal to 1 over u. And then substituting what we have, this is 1 plus x to the power 5 plus 1 by x to the power 7 plus 2 squared plus c. Now let's use another piece of information we have that I didn't include in the problem, that f of 0 is equal to 0. So if we plug in 0 to this, we see that it's undefined, therefore our c, constant of integration, is 0. So now when we plug in 1, what do we get? 1 over 4. So in other words, we have f of 1 is equal to 1 over 4. And that's our answer. The next question is actually kind of an interesting one. Let me just write it down here. So we have, for all, let n be an integer, n is greater than or equal to 2. And we also have theta from 0 to pi by 2. And now we want to evaluate this indefinite integral. It is sine n theta plus sine theta, minus sine theta raised to the power 1 over n over sine n plus 1 theta cosine theta d theta. Now our cosine, if it isn't immediately obvious, seeing the cosine theta d theta makes us want to do a u substitution, namely sine theta is equal to u. So if we do sine theta is equal to u, we get cosine theta d theta is equal to du. Okay. U to the power of n minus u raised to the power 1 over n, u to the power of n plus 1 du. Now we have to find out a way to do this algebra. What I did was I took out the u to the power of n in the numerator. Doing that, what do we get? U to the power of n, 1 minus 1 over u to the power of n minus 1 raised to the power 1 over n. This whole thing raised to the power 1 over n, correct? We can simplify this to u times 1 minus 1 over u to the power of n minus 1 raised to the power 1 over n. Correct? Yep. So now we've simplified the numerator a little bit, and now we can bring the u to the power of n plus 1 term over to make this integral u to the power negative n, I believe. U to the power of negative n into times 1 minus, we see that we have a 1 over u to the power of n minus 1. Let's just make that u to the power 1 minus n. Minus n, and then of course we have the du at the end. Correct? Seems correct. Yep, okay, so now what? We see u to the power of n du, and we also see a 1 minus u to the power 1 minus n. This tempts us to let our 1 minus u to the power of n, we've already used u, so we'll call it t now. From what do we have? Since this becomes minus 1 minus n u to the power of minus n du is equal to dt, right? How can we simplify this from here? Because we're given n is greater than or equal to 2, we don't perform the chain rule. So we have u to the power minus n du is equal to dt over n minus 1, right? Just distribute the minus 1 and divide by that. What's not so cool about that is now we can write our integral as follows. Dt over n minus 1 times t. Yes. So now we know that 1 over n minus 1 is a constant, as I just mentioned. So this just becomes t dt. Now this is good. Now we can just integrate this because we have a t and then a dt. So this becomes 1 over n plus 1 times t squared over 2. Right? now what? T squared over 2 1 minus, I'm just making sure I'm doing this correctly. 1 minus u to power 1 minus n, we let this equal to t. So we have minus 1 minus n u to power. I forgot something. We need to put this as 1 over n. Right? We forgot the 1 over n from the back page. So this is actually not t squared over 2. Since after all we're integrating 1 over n, make sure always check your work. Now we can do this now. T to power 1 over n, let's just write it as t to power 1 over n plus 1 over n plus 1. Right? I'll work a little faster now. 1 n minus 1 times what can we simplify as t to power of n plus 1 over n. And then we have n plus 1 over n. This becomes n by n over n squared minus 1 times the n plus 1 over n. This is what I'm getting. Let's just put n plus 1 over n, n plus 1 over n, n plus 1 over n, and t to the power of n plus 1 over n. Seems correct. Okay, so now what can we do? This is our integral. Now let's just substitute what we've done. We let t equal 1 minus u to the power 1 minus n. Subbing that in, we get n times n squared minus 1 times 1 minus, what did we let u as? We let u equal sine theta. Sine theta raised to power 1 minus n raised to power of n plus 1 over n. And that should be your answer. We can obviously do some simplification, but n over n squared minus 1 times 1 minus sine theta raised to power 1 minus n to the power of n plus 1 over n should be the final answer you're getting. Next question. This is question number 4. If x to the power phi e to the power minus 4x cubed dx, so we're given an integral and we're also given that it is equal to 1 over 48 times e to the power minus 4x cubed f of x plus c, where c is a constant of integration. We wish to find f of x. So how can we do this? When we're given integrals like this, we obviously can't by parts. We can't obviously use integration by parts in this, but we can do a clever u substitution. Namely, let minus 4x cubed is equal to t. If this is not immediately, equal to u. If this is not immediately obvious, it should be soon. So upon differentiation, we get minus 12x squared dx is equal to du. Or in other words, we can rewrite this as x squared dx du over minus 12. Okay, that's great. We have x squared dx is equal to du by minus 12, but it'd be ideal if we could have x to the power phi dx. Luckily, that's not too far of a stretch because we've substituted our minus 4x cubed equal u, so x cubed is equal to u over minus 4 by just dividing by negative 4. So now we have x to the power phi dx is equal to du minus 12 times u over minus 4. This becomes 1 by 48 u du. Right? So now all we have to do is we got to integrate, pull the constant out of the integrand. So we have u du, u e to the power of u du. U e to the power of u is actually a very simple integral. We can just do by parts. So 1 over 48. Now what do we need to do? We'll let u be the function we want to differentiate because that's easy to eliminate from differentiation. We let e to the power of u be the function we want to integrate. So this becomes u e to the power of u minus integration and differentiation of the first function times integration of the second function minus e to the power of u. This should be your answer, but now we got to do our substitution. 148 times minus 4x cubed e to the power minus 4x cubed minus e to the power minus 4x cubed. Now we see we're getting closer and closer to the ultimate function we want. We can take a e to the power minus 4x cubed out of here. And we can multiply by minus 4x cubed minus 1 plus c. So we can immediately see by pattern matching that f of x is equal to minus 4x cubed minus 1. And we move on to the next question. Question 5. We have root 1 minus x squared, x to the power 4 dx is equal to some function a of x root 1 minus x squared raised to the power of n plus c. How are we going to integrate this? Originally, what I did was I did the same integration technique we did in 3. It's by taking the highest power out of the numerator slash denominator. Right here, looking at this for a second time, I also see that trig substitution may work also, but for the sake of now, I'm just going to do it how exactly I solved it when I did it the first time. So we look at our root 1 minus x squared. We take out the x squared term from this, and this is actually a very popular thing to do in these kind of questions. And then this becomes x to the power minus 2 minus 1, right? 1 minus x. Yep, that should be correct. Now we raise this to power 1/2. Same thing as the square root. This becomes x, and then I'll write this as square root. So we can rewrite this as we've got a different representation of the numerator. We bring the x to the power 4 into the numerator. This becomes x to the power minus 3 root x to the power minus 2 minus 1. And now this is immediately bingo, because if we differentiate x to the power minus 2 minus 1, we get minus 2x to the power minus 3 dx. So doing what I said, we let x to the power minus 2 minus 1 equal u squared for simplicity of calculation. And then now we calculate minus 2x to the power minus 3 dx is equal to 2u du. Or in other words, x to the power minus 3 dx. Dx is equal, x to the power minus 3 dx is equal to minus u du. To minus u du. So we can rewrite this integral as minus integral of u squared du. This becomes minus u cubed over 3. What does this become now? Minus u cubed over 3. We substitute what we put in as u, which is cubed, so this actually becomes x to the power minus 2 minus 1 raised to the power 3 over 2 over 3 negative. Okay, we want this minus x to the power minus 2 minus 1 raised to the power 3 over 2 over 3. We want this to be in the form of this. So how are we going to do this? Well, we write this as minus 1/3 x to the power minus 2 minus 1 raised to the power 3 over 2, getting a little closer. But we want it in the form 1 minus x squared, not x to the power minus 2 minus 1. So I've used up the whole page. Let me go to a different one. So we have our function x to the power minus 1. This is just 1 over x squared. This is equal to 1 minus x squared over x squared. Right? Now remember raising this to the power 3 over 2. This is equal to 1 minus x squared. 3 over 2 raised to the power x cubed, right? Simply this. Right. So minus. So this becomes minus 1 over 3x cubed times 1 minus x squared raised to the power 3 over 2. And this is in the form of a of x times the root 1 minus x squared raised to the power of m. And now what the I'll even write it out for you. We can see it's in this exact form where our a of x is minus 1 over 3x cubed and our m is 3, right? So now we want to find a of x raised to the power of m. In other words, minus 1 3x cubed raised to the power of 3, and this is very obvious. It's minus 1 over 27x to the power 9. Okay. We'll go to the next question. Question 6. Question 6. Okay. Root x plus 1 over root 2x minus 1 dx is equal to another pattern matching question. F of x root 2x minus 1 plus c. Now we may be tempted to do the same technique we did in the last integral, which is like take the highest power common, but you can try that and you see it won't work. This is mainly due to there only being like a linear term. This is a linear term, so that's why it won't work. We can even try, we take root x out, we get root x times root 2 minus 1 by x to power of, yeah, we just do that, it just won't work. So instead, we note that we can actually make this a lot simpler by making a u sub. Namely, we let 2x minus 1 equal u squared, right? Therefore, we have 2 dx is equal to 2u du. So we have dx is equal to u du. Dx is equal to u du. Okay. So now we can represent dx as u du. We can represent our root 2x minus 1 as u. But in order to solve this integral, we need to represent x plus 1 in terms of u also. In terms of u. So how can we do this? Well, it's actually pretty close to u squared. I mean, if we double, we get 2x plus 2. And u squared is 2x minus 1. 2x plus 2. So this is actually just equal to u squared plus 3 over 2, right? So integral of u squared plus 3x, u squared plus 3 over 2. And then we have a u, but that cancels with the u du as equal to dx. So this is just integral of u squared plus 3 over 2 du. That makes sense, hopefully. Now what? Now what? This is just an easy integral. U cubed by 6 plus 3 over 2u. Okay, this is equal to, now let's sub in what we, 2x minus 1 raised to power 3 over 2 plus 3 over 2, root 2x minus 1. This is our integral. We need to pattern match this as f of x, root 2x minus 1 plus c. So root 2x minus 1, the easiest way to get that is we just simply factor the root 2x minus 1. Factoring, we get 2x minus 1 over 6, because 2x minus 1 is just 2x minus 1 raised to power 1 times 2x minus 1 raised to power 1 half. We just add the exponents, becomes 3 over 2 plus 3 over 2. This is equal to root 2x minus 1. We can simply do this. 2x minus 1 plus 9 over 6, that's 2x plus 8 over 6, that's x plus 4 over 3. Plus c, since we can pattern match and see that x plus 4 over 3 is equal to our f of x. Integral of, next question is integral of cosine of log base e of x dx. This is kind of an interesting question. We have a composition of two functions, right? And we only want a single function that's easy to integrate as well. So our first attempt is to let log base e of x, or ln x, equal to u, and then we have e to the power of u is equal to x. So we have e to the power of u du is equal to dx. E to the power of u du is equal to dx. Okay, so now this just simplifies to cosine of u e to the power of u du, right? E to the power of u du is our dx, and log base e of x is our u. Next what? We can do integration by parts by simply letting cosine u as the function we want to differentiate and e to the power of u as the function we want to integrate. This becomes, we'll let this equal I, so this becomes cosine u e to the power u minus integration of differentiation of the first function is minus sine u, so that just cancels to become a plus sine u, and then e to the power of u. Okay, now we need to by parts to sine u e to the power of u. This becomes sine u e to the power of u minus integration. Differentiation of sine of u is cosine u e to the power of u. And we realized that this will actually be an endless cycle, because it'll just go like this and like, but we can easily terminate it by realizing that this is our original integral. So we have I, the original integral, is equal to cosine u e to the power of u plus sine u e to the power of u minus I, right? So solving for our integral gives us I is equal to 1/2 times cosine of u e to the power of u plus sine u e to the power of u. Now all that is left to do is sub in our value for u, which is log base e of x. Cosine of log base e of x, and then e to the power of u is log base e to the power of log base e of x, which is just x. That's common for both, so we can just factor it out. Plus sine of log base e of x plus c. This should be our answer. Next question is question 8. Oh, we're only on question 8? Okay, I gotta go a little faster. This becomes 3x 13 plus 2x to the power of 11 over 2x to the power 4 plus 3x squared plus 1 raised to the power 4 dx. How are we going to do this? We're obviously not going to expand the denominator, and we're obviously not going to try to do partial fractions if we even can. So what we're going to do is we're going to do the same integration technique by taking the highest power out of the denominator. Doing that, we get x to the power 4 times 2 plus 3x to the power minus 2 plus x to the power minus 4. Of course, this whole thing is raised to the power 4. This simplifies to x to the power 16, 2 plus 3x to the power minus 2. Raised to the power 4, correct? This becomes... Yep, now we can take x to the power 16 to our numerator. This becomes 3x to the power minus 3 plus 2x to the power minus 2. Am I doing this? Let me just double check my work. X to the power 4, 2 plus 3x to the power minus 2 plus x to the power minus 2 raised to the power of x to the power 16, 2 plus 3x to the power plus 6. Seems correct. Okay, so we have 3x to the power minus 3. I thought this was a 4. It's actually 11. I should be more clear. 11 plus 2x to the power minus 5 over 2 plus 3x to the power minus 2 plus x to the power minus 4 raised to the power 4 dx. Well, now the differentiation of the denominator is in some form of the numerator. So we let 2 plus 3x to the power minus 2 plus x to the power minus 4 equal u. From this we have minus 6x to the power minus 3 minus 4x to the power minus 5. The dx is equal to du. Dividing by minus 2 both sides, we get a desired numerator. So we have 3x to the minus 3 plus 2x to the power minus 5 is equal to du over minus 2. And then u to the power 4. So this becomes minus 1/2 integral of u to the power minus 4 du. Okay, yep, this seems correct. This becomes minus 1/2 times u to the power minus 3 over minus 3. This becomes u to the power minus 3 over 6. Or in other words, this just becomes 1 over 6u to the power 3 or in other words 1 times 6 into u cubed 2 plus 3 by x squared plus 1 by x to the power 4 raised to the power of 3 plus c. This is your answer. And the steps I'm doing is kind of redundant. I'm just doing it just to like show you guys. But normally you should be able to do the thing I did in your head. So our next question is question 10, which is dx over x cubed 1 plus x to the power 6 raised to the power 2 over 3 is equal to x f of x. 1 plus x to the power 6 raised to the power 1 over 3 plus c. How are we going to do this? Well, we can't do any clever use substitution right off the bat. So let's just try the same technique we did in the last time. In fact, this is actually a very common integration technique. You try to use it for any integral that you see it may work. So we look at our 1 plus x to the power 6 raised to the power 2 over 3, and we factor out the x to the power 6. X to the power 4 times x to the power minus 6 plus 1 raised to the power 2 over 3, right? This is what it factors to. Okay, so x to the power 4 combines with x to the power 3 to become x to the power 7, and then that goes to the numerator to become x to the power minus 7 over x to the power minus 6 plus 1 raised to the power 2 over 3. This becomes our dx, okay? And now the differentiation of the denominators in some form of the numerator, which is really good. So we have, I'll just jump straight to it. So we let x to the power minus 6 plus 1 equal u, so we have minus 6 x to the power minus 7 du is equal to dx, or minus 6 x to the power minus 7 dx is equal to du, or we have x to the power minus 7 dx is equal to du over minus 6. So it becomes integral. Actually, for simplicity of calculation, I'm going to let x to the power minus 6 plus 1 equal u cubed. Therefore, we have basically the exact same thing. Du for du by minus 2. So this becomes integral of u squared du over minus 2 over u squared, minus 2 u squared. Okay. That seems it. Cancel, cancel, minus 1/2 u should be the final integral. We just substitute in back the thing we have, minus 1/2. What do we put our u as? So x to the power minus 6 plus 1 raised to the power, let me sharpen the pencil real quick. Minus 1/2 x to the power minus 6 raised to the power 1 over 3 plus c should be our answer. But now let's compare it to what we need, which is over here. F of x times 1 plus x to the power 6 raised to the power 1 over 3. X to the power minus 1 plus x to the power minus 6 plus 1 is now 1 plus x to the power minus 6, so we attempt to simplify this. X to the power 6, next we have to raise this to the power 1/3. This is equal to x to the power 6 plus 1 raised to the power 1 over 3 over x squared. So this is minus 1 by 2x squared times x to the power minus 6 plus 1 raised to the power 1/3. See, now this seems to match our function of the pattern we want here, except for the x. So they try to trick us over here. So this actually needs to be, if we want x here, this must be cubed. So this is our function over here. Minus 1 over 2x to the power, minus 1 over 2x cubed. So this is hopefully the last piece of paper I'm going to use. What is the integral of... Okay, this is not the same trick. Fortunately, it's something different. Cosecant 4/3 x dx. Okay, so now we're going to use another common integration technique. Okay, first we realize that secant and x or cosecant of x are not best friends in the integral world because they're not even closely related to each other. So what we need to do is we need to do something to get rid of those. In fact, this is actually kind of a common integration technique. Whenever you see like two things, try dividing by secant 2/3 x. Secant 4/3 x. Secant 4/3 x. This does two things for us. Number one, it makes this a secant squared x. Number 2, cosecant 4/3 x over secant 4/3 x is equal to cotangent, is it? Yeah, it's equal to cotangent 4/3 x. And then we know tangent and secant are best friends. So we can probably do something about this. So as I said, secant squared x, 1 by cosine over 1 by sine over 1 by cosine by sine. Cotangent 4/3 x dx. So we've simplified the integral to this. Now we want them to be best friends, so you rewrite this as secant squared x over tangent 4/3 x dx. Now we can do a desired substitution. Tangent of x is equal to u. That brings us secant squared x dx is equal to du. So this becomes the integral of du over u to the power of 4/3. We integrate this as u to the power minus 1/3 over minus 1/3. It becomes minus 3u to the power of minus 3u to the power minus 1 over 3. This becomes minus 3 tangent minus 1 to the power minus 1 3x plus c. This should not be confused with the inverse tangent function. Good. Okay, so we actually have 4 more questions until we're done. So let's try to finish them up real quick. Next question. Integral of e to the power secant of x, secant of x tangent of x, f of x, plus secant of x tangent of x, plus secant squared of x, dx. So we have the integral of this. We're given some f of x term, and we're given that this is actually equal to e to the power secant of x, f of x plus c. And we want to find the possible choice of f of x. How are we going to do this? Well, we're given the answer, so if we differentiate the answer, we must get what's inside the integral, right? That's just a cheap shortcut, so let's just do it that way. So if we were to differentiate e to the power secant of x, f of x, this is the product rule mixed with the chain rule. Let's see if I remember. So this becomes e to the power secant of x. So we take the derivative of e to the power secant of x. It's e to the power secant of x times secant of x tangent of x. F of x g dash plus. And then now we just leave this as its own. Secant of x. Now we differentiate f of x, which is just f prime of x, which is derivative of f of x. Next, what? Next we factor this. E to the power secant of x times secant of x tangent of x. E to the power secant. I forgot the f of x here. So f of x. Over here I just forgot to write the f of x. Plus f dash of x. Okay, now we can pattern match to this. We see it's very identical, and we're given the derivative of f dash x is actually equal to, we're given f dash x is equal to secant of x, tan of x, plus secant squared x, right? So if we integrate both of them, we get f of x, since they're both inverses, is equal to integral secant of x tangent of x plus secant squared of x. We just recognize that as a bunch of easy integrals. It's just secant of x plus tangent of x plus c. Now over here in the answer choices, it would be secant of x plus tangent of x plus 1/2. This is a choice of f of x. Obviously c can be anything. In the answer choices it shows this, and that's the only option that works. Next question. Next question looks interesting. Dx over x squared minus 2x plus 10 squared. Okay, this is I'm just going to write it down. A tan inverse x minus 1 over 3 plus f of x over x squared minus 2x plus 10. So we gotta somehow simplify this monster to that monster. Oh god. So our first thoughts are, obviously we're not gonna be doing partial fraction.